All right, 4.3 Part 2 is solving using the Fundamental Theorem of Calculus, FTC, Fundamental Theorem of Calculus, in application. So I'm actually going to show you how you can use your graphing calculator to do this. Now, I still want you to know how to do it by hand, which is why Part 1 was all about how to do it by hand. But sometimes we can't. There's actually applications for us that we can't solve by hand. And so you have to use your graphing calculator. All right, so how to use it, again, it's a tool you should have. It's important, and again, it's a very helpful tool. And it gives you a good idea what's happening graphically. All right, so using the graphing calculator, solve the definite integral the way I want you to do it. Now, there's another way, but I want you to do it this way so that you can see the accumulated sum. So you can see the area that you're adding up. All right, so remember, the Fundamental Theorem of Calculus states, we solve the definite integral, which is the sum of my function f of x between point A and point B, as long as my function is continuous. So I find any antiderivative, so we typically do the general case, plug in my upper value and my lower value, and take the difference. Alright, now there will be some cases where you cannot solve things algebraically. Right, so we will use the graphing calculator. Now in applications I will allow you to always use the graphing calculator, alright, but there will be some cases where I'll say solve it by hand, and you are to solve it by hand and show the steps. Alright, how you do this if you have an 83 or an 84, and Inspire has a similar program. If you've got some other calculator, again, there should be a way to do it in almost all graphing calculators that allow you to graph. You should be able to find any accumulating sum. Alright, so graph f of x. Remember, this is the function we're graphing, not the general antiderivative. We're graphing the original function that's inside the integral, right? Little lowercase f of x is what's graphed. Alright, make sure the x values are included. So if a is 10 and b is 100, you have to make sure your window's big enough so that it shows 10 to 100. So you have to expand your window. Alright, make sure your x values show up in your window. So you have to adjust your window accordingly. Alright, then you're going to hit second, and I'm going to go through this in a second on an example. You're going to hit second trace, alright, once you've got your picture graphed. And then number 7 on that list is the integral. You'll see it's the integral f of x dx. You'll see that that's what number 7 is. Then it'll ask you for the lower bound, where you type in the x value a. Then you hit enter. You ask for the upper bound, you type in the x value b. And then the calculator will shade in the region for you. That's why I want you to do it this way, so it shows you the areas shaded in. And it will find that difference in b minus the difference in a. Alright, so I'm going to look at an example. And the only downside to solving it this way is you don't get exact answers. Alright, but sometimes we have to. So an example would be, suppose I want to integrate 0 to 2 of the function 10 times 3 to the x with respect to x. We don't have a way to find the antiderivative of 3 to the x. It doesn't exist for us. Alright, now there is a way, but we don't do this. And so you guys cannot find the general antiderivative of this. So the only way to solve this is graphically. And so you go to your calculator, you type in 10 times 3 to the x. Now we will have to change the window. What I do is I just zoom out so you can see the picture. Because it's well, actually zoom out. I'm not sure if I zoom out. I might just change the y value. Change the y max to 300. Alright, so I'm going to go to my graphing calculator. I believe I've already got it typed in. So I've got 10 times 3 raised to the x. So make sure you plug it in there correctly. It's 10 times 3 raised to the x. And then I will change my window. So I'm going to go to my window. And it looks like I changed it instead of my... So I left my negative 10s and 10s for my standard window. The only thing I changed was the y value. Because again, the y value is fairly large. Because I'm taking 10 times 3 to a power. And so I went to 270, 300 would be close. Because if I plug 2 in, I get 90 out. Alright, so once I've done that, now I'm going to go to my graph. Alright, so there's my picture. There is the graph of 10 times 3 to the x. Alright, now to find the accumulated sum. Well, you hit second trace. And if you see there, number 7 at the bottom, there's the integral. Integral of f of x dx. And so you select 7. And then the calculator will ask you the lower limit. And so you type in the lower x value, which in this case was 0. Hit enter. Then it'll ask you for the upper value. The upper value is 2. Hit enter. And then it'll shade it in. Alright, and so, and again, the downside is it doesn't find it exactly. Alright, so it's the 72.81938. So if you're solving this on your homework or quiz, All right, what you want to show for this is I'm going to solve this graphically. You show the graph. All right, so this is the graph of that function, and then 0 to 2, and then you show what the picture on your calculator gives you. All right, that finds this definite integral, which was 72.819 if I draw the graph. And it actually is the area in this case because it's completely above the x-axis. All right, so again, if we're solving these by hand, actually this case you can't solve this particular example by hand. All right, but so if you're solving on the calculator, this is what I want to see. I want to see the integral you solved, the final answer, and then the picture that allows you to get that answer with the shaded in region so that we understand that's what you're solving. All right, so let's do a second example. Let's integrate from 10 to 25 the function negative 30e to the negative 1/2 t dt. All right, well now this one I could find the general antiderivative of, but I'm going to solve it graphically. So again, you would graph the function negative 30e to the negative 0.5t, which actually when you go to plug that in the calculator, you can't plug t in, you have to plug x in. Alright, so I'm going to go to my graphing calculator. I'm going to clear out what I have here, type in my negative 30e to the negative 1/2 x. Alright, now I'm going to adjust my window. I'm going to leave my x values, no, I'm not going to leave my x values, I have to change my x values. So remember, in order to graph the right region, I have to make sure my picture shows me my x values. So if you remember, the x values were from 10 to 25. Well, if I don't change my x max, I won't have 25 on my window, and the calculator won't be able to find the definite integral. So I have to make sure my x value includes 25. So I'm going to go 30. All right, then I know I make sure that it's definitely 10 to 25 is included. All right. And then I'm going to kind of look at my table here. I might just change these back to 10s and be fine, although I think the values are small. So I'm going to leave it I'm going to leave it like that and see if that gives me a good enough looking window, which it does look like it does there. So I'm going to hit graph. Alright, so there's my function, hopefully, if it pops up. There it finally comes. And then the area we want to find is from 10 to 30. Alright, so I may have wanted to zoom in a little bit because it's going to be a little hard to see, but I'm going to leave it. So I'm going to hit second trace, 7, lower value 10, upper value 25. Right? And if I hadn't had the 25 in my graph, the calculator would give you an error. So it's this little bit of error. It's not very big, right? It's all negative because it's all below the x-axis, and it's less than 1/2 of a unit of area. It's really close to the x-axis there. So negative 4.04. So if I go back and I show the picture, so again, if you're solving this, so the graph, all right, it's coming up really close to the x-axis, and again, we're integrating from 10 to 25, and it's just a little tiny bit, so tiny that you actually can't even see it when you look on the graph, but that is the area we're finding. All right, that is negative 0.404053, if I remember correctly, which solves this integral, negative 0.04053. All right, and that's how we solve it graphically. All right, so we're going to look at applications since we now have this graphical method. If you're solving it graphically, this is what I want to see. I want to see your integral, your answer, the graph with the area shaded in that solves that's solving. All right, that's the area that's shading. So this is what I want to. This is the work that you have to show. All right, we'll stop there. I'll pick up the applications in the next.